All right. Welcome in, everyone. Hey, hoo hoo. All right. We're good. How are you today? N times theta? What does it mean? Oh, interesting. Spectrate? You got first. Tired? Hopefully he gets some rest. I'm doing good. I'll say I haven't been getting much sleep the last few days because I've been going to bed late and waking up early, but I don't feel that tired. I did Spectrate. I actually remember to run my bot before I went live, thankfully. Spectric claimed the first redeem though, so the record shows Spectric was first. And I looked a bit more into getting the first leaderboard, not like this. I was more into getting that like first leaderboard thing working, and it's actually going to be harder than I thought. I still really want to do it, but take a little bit of work. Got 4 of them, nice. I know who are. So I'm curious because I haven't asked about it in a minute. Are you still doing that like photo club? How is that going? Or like a photography club? All right, so we have this vector function, this parameterization, integral of an oriented curve, right? Wrong. Let's see. Pretty sure that person did it right. He just got first and left. There we go. The year you were born, but it's 1900 BC. Respect your elder. Okay, so this is the point the person was using. No, I think he's saying that he was yeah, like 1900 BC, like in ancient times. No, you would be right if it was the year like 1900 AD. I don't know. Do people in other countries call it BC and AD? Like, I guess who in France, what do they call it? Like the year before zero. Because like we're in the 2000s now, but before the year zero, we just like start counting backwards to like the year like 1 BC. In Germany, you do? Okay. I don't know if that's like a language thing or like how universal that is, I guess. You don't know? All right, all right. I won't pressure you. I won't make you do more math. You can just hang out. Hard locked, yo. It sure is math time. We got a triple. Oh no, we just have a. It's not a triple number. We just have a line integral on our hands that I'm trying to get to the bottom of. Hope that you've been good. Most effective way of solving a cubic equation? Bio, either it's possible to group the equation or you're screwed. Well, no, you're not screwed, necessarily. Do you know what grouping is for a cubic, though? It doesn't, it only like rarely works, but it's a really simple way to solve them if it does work. Factoring? Basically, it's factoring in a way that people don't usually see it though, so I'll write an example on the board here. Wait. Okay. So when I say grouping, oops, come on, cord. Oh, okay, that's as much cord as I get. Anyway, when I say factoring, I mean if you have something like, let's call it x cubed plus 2x plus, 2x squared. Let's call that 2x plus 4. This is groupable because you take those two terms and those two terms and you group them. So from these two, I'm going to factor out the thing they have in common, which is x squared. It's not plus. You just get x plus 2 left over. Plus. And then from these two, I'll factor out the thing they have in common, which is 2. And now we notice they both have an x plus 2 in common, so we factor out that x plus 2. You end up with x plus 2 times x squared plus 2. So that's the easiest way to solve a cubic, but obviously you have to get this nice like matching thing there. I don't know if you know that. So yeah, but that's like, if it does work, it's great. It's really quick to do. If this doesn't work though, then you have a lot of work on your hands. So like if you instead had I don't know if this is going to be factorable, but like a 3x there, and you have to do everything by hand, your best choice is the rational root theorem, which kind of takes a lot of work. But do you know what the rational root theorem is? I'm not charging my phone, by the way. I should charge my phone. Oh God, don't jiggle on me, camera. I don't like it when you jiggle. Guessing and polynomial method. Yeah, that might be. I think we're talking about the same thing because the rational root theorem is basically guessing. So you take the constant in all of its factors, and you divide it by the leading coefficient in all its factors. So in this case, we just have a 4 and a 1, and you have to do pluses and minuses as well. So you have 4 is a factor of 4, plus or minus, technically divided by 1 because it's the leading coefficient, but dividing by 1 doesn't do anything. Plus or minus 2, which is another factor of 4, and then plus or minus 1, which is the last factor of 4. So you have, 6 different things because you have a plus or minus for each, and you just plug them all in and hope that one of them works. Well, one of these has to work because it's a cubic, right? How, though? Oh, yeah, it has to be a negative. Would -1? No, -1 doesn't work. -2? You get -8. -6 is -14. You get 6, no. 8 plus 4 is 12, no. So -4 must be it. So -64 minus 12 is -76. No, that doesn't work either. I don't know. Well, one of those has to work, but I'm doing my mental math wrong. But basically, those are your candidates, and you try plugging them all in. Why is there a minus? It's just basically what the rational root theorem says. You take all the factors and you consider both the positive and negative versions of those factors. I think because you just know for a polynomial that you can't have positive or negative roots, you just be more expansive in your search. But these are your guesses that you would try to like plug in and see which one works. One of them has to work here for a cubic, but I don't know which one does work. Well, actually, no, one of them does not have to work. It could be irrational. Never mind. So this might actually have irrational roots and imaginary. So of course it's called the rational root theorem. It only works for rational roots. If there aren't rational roots, then you'll find that none of these work and you wasted your time. Well, it's not a waste, but it doesn't have rational roots. And if it doesn't have rational roots, then you're done for. There's a cubic equation, but it's horrible. Yes, that's the cubic equation. Or cubic formula. I don't even know what it's called. Cubic equation. You could use that. I never used it because it's terrible, but you could use it. Yeah. So if you're a fan of this equation that takes up 2 lines on this page, more power to you. I'm not. There's also one for Quadratics too, and it's even worse than the cubic. It's not necessarily less work than the cubic formula, but I feel like for the kind of math that I've seen you do, you might get quiz on Vietta's equations, formulas. I don't know them very well, but I believe they're a way of finding zeros as well. You get a bunch of systems of equations though, and it's kind of, you know about them? Okay. So yes, the coefficient method works for any polynomial. It might be a lot of work, but if it has rational roots, it'll work for any polynomial. So like they do an example here on this site. Just taking the coefficient of the leading term and the constant. Exactly, yeah. So with this one you have 6, it's a -6, but we're gonna do plus and minus anyway, and a 2. So you do all the factors of 6 divided by all the factors of 2. So you get a bunch of different combinations. They list them all. Oh, yeah. So yeah, I guess like these end ones are all the things that you need to try to plug into the original formula and see if they work. Hey, underscore, in the academic context, you always have at least some rational roots. If you have a nice teacher, yes. I feel like I've seen students come with problems that don't have any rational roots, and I don't really know what they're supposed to do. Yeah, no problem, bio. Higher degree polynomials are just hard to work with to find their zeros, unfortunately. If they don't group, then you have a lot of work ahead. Okay, in the meantime, I got beaten to the punch by Gamma Ray Burst. This is probably right. No, I don't think AI will replace us all. Oh gosh. What is this? I'm not smarter than AI. I just think AI is a tool that people are going to use, or a tool for people to use. Oh wait, I bet you use there's a product formula that you use here. So what you okay? First off, just try to plug in 0. You get sine of 0 on the bottom, which is 0, so that's bad. You get tangent of 0 on top, which is 0 and not undefined. And you're not allowed to use L'Hopital, so it must be a trig identity. Credit for lawyers and doctors. What I'm imagining is we need... Oh, there... Aren't there formulas for when you have the product of an angle? That 3 pi, like... It's making me wonder. Is that solved via Taylor expansion? Oh, yeah. Yeah, I'm kind of curious just to look at the graph of this. I mean, they're in grade 12 calculus. I guess they could be doing Taylor series, but that's a lot to expand. You might actually be right, though, the more that I think about it. Tan 3 pi sine. What's our... Oh, to the 6. Okay, 10 to the 6, 7x to the 4th. 10x to the 6 minus 7x to the 4th. Patrick, you don't need to apologize. You don't need to... You're not required to come to the stream. What the f... What is this? This is like a reverse sine 1 over x. What the hell? And why is it... This is just a point here. Oh, it's undefined at that exact point. This looks like 3 pi. So there must be some crazy thing. There must be some kind of crazy cancellation. I feel like there's some kind of algebraic thing that you can do here. This is... It's quite the function right there. I don't know why it behaves like that. I guess because of the polynomial inside it does that? Okay, so I'm expecting an answer of 3 pi. I don't know. I don't think you get anywhere by, like, factoring this. They do give you something that's factorable, though, which is kind of confusing. You could absolutely give this like 3 terms for this or something. U equals sine of nonsense. I don't see why not. I still don't know what we use here though. Or like where we go. I thought there was some kind of identity we could use to split up the 3 pi and the sine, but I guess not. Tan of 3 pi x over x and x goes to 0. Oh. Okay, well that's simple. Okay, that's probably a good call. How do we, so tan is sine over cosine. So you do have a sine x over x built in there, but the cosine, how do we deal with the cosine? The cosine is just gonna be 1 and maybe, oh. Okay, yeah. I think I like that. It's a cosine, you can do it with a product. Okay, let me just draw this out. All right. Yeah, I didn't see where that was going at first, but thank you for spelling it out for me. Okay. So we have the limit as x goes to 0, tangent 3 pi x to the 6 minus 7x to the 4th plus 3 x squared. I'm amazed that I remembered all that. I'm pretty sure I'm right. 10x to the 6 minus 7x to the 4th plus 3x squared. Hey, look at me. Okay, so yeah, let's do what Stupi said and take u equal to sine 10x to the 6 minus 7x to the 4th plus 3x squared. As x goes to 0 here, u also goes to 0. So we can make the swap directly here. We end up with tan 3 pi x over x. And now, u. Okay. Now tangent, we have to remember sine over cosine. 3 pi u. I don't know why I spaced it out like that. Cosine 3 pi u. Now we recognize sine x over x here, so we want to split this cosine off into its own limit. We're not going to have any issues there because cosine of 0 is 1, so we don't get any division by 0. Sine of 3 pi u over u. Normally, so limit of sine x as x approaches 0 is 1. That's just for x. It's not for 3 pi times x. And to do that, I believe it's just a change of variables that you do to prove that this, when you have 3 pi there, it's going to equal to 3 pi. If I say like v equals 3 pi x. No, x equals 3 pi v, right? As x goes to 0, 3 pi v also goes to 0 still. Multiply each side by 3 pi. This is just a constant. Why is that a 1? Three pi. All right. So we get 1 from that limit. We get 3 pi from this limit. So we just get 3 pi. All right. Thank you both. Kind of a neat problem. Hey, Rowdy, 7. Pretty close. So like big O and small o. Yeah, you're probably right. Underscore. I never learned the big O stuff. I know it's like overpowered for evaluating limits, but I just never really learned it. Okay. Let me put my mug away and see if someone has replied to it. That's a good question, Stuki. I always have been. I guess we need to check the spreadsheet to see. I think Enigma thought of that, and they both work. I feel like Enigma's talked about that at least. I would have to look at the spreadsheet again because I haven't looked at it in very long, in a long time. If there's separate entries for like Ian Stuki and at Ian Stuki, I guess that's a problem, and I should stop doing the at. What? This explanation isn't particularly clear to me. It gets to the right answer, and I think uses the right idea. When I read it though, I have a very hard time understanding what's happening here. So I think we're gonna the method that we did. Hey, Jed. A change of variables here. And this is oops. I'm using the royal I here, which means that I'm taking the credit for an idea that you guys put in chat. A change of variables. U equals sine 10x to the 6 minus 7x to the 4th plus 3x squared. Here's the real. Well, that's because I just invented it now. I wish that I could do some kind of a formatting here, but this is the best that I can do on Reddit. Tan 3 pi. Oh, I can do at least the character for pi. I mean, I keep forgetting to do the math symbols commands. No. Open. Oh my god, when I right click on a hyperlink, it says to open as the first option, not open a new tab. Pi. Tan 3 pi u. I don't know why I did the bracket. I don't need that bracket. For u. Sine over cosine. U goes to 0. Sine 3 pi u over u cosine 3 pi u. I'm just giving the answer because this is a difficult problem. It's a sneaky sine x over x limit here, that the cosine is in the way. So let's split up the limit. Limit as u goes to 0 of 1 over cosine 3 pi u times limit as u goes to 0 sine 3 pi u over u. The first limit evaluates to 1. The second limit you may have just learned as a formula. If you know sine x over x approaches 1, show it with, it's a formula to be 3 pi, or if you know that sine x over, or just know, you can show it by doing another change of variables with x equals 3 pi v, and you'll see you'll also get 3 pi. Okay. I don't know what I typed to get that prompt. All right, that's my answer. I'm sticking to it. Frederick, yeah, I'll do a solve for you now that I have a minute. Do a scramble. All right. Inspect. Okay. Oh, this is already terrible. Oh my god, this is terrible. 26 seconds? All right, I could have done a lot better, but oh well. Actually, wait. What does sine of x squared look like? Okay, it kind of does that like same thing. So it is like the high degree on the inside of the sine that does that kind of weird period thing. Okay, that makes sense. I was curious about it. Okay, now I can't close out of this Desmos tab. Great. Okay, there. Small is when an expression is negligible compared to another at a certain point. Okay, fair enough. Underscore. Not Frederick. Solving Rubik's Cube is just memorization. It's not being smart. Oh, this problem just really takes a ton of time. It's Vieda's, I think. Well, you might be able to do it without. Find the values of k if the quadratic equation has consecutive roots. And I assume they're talking about like integer roots. Oh no, I guess it's not necessarily Vieda's. Oh yeah, I'm sure it does underscore. I can't. It's kind of hard to learn a concept when it's just someone typing to me at Twitch chat. So I kind of stopped trying to analyze it that much. I'm sorry, but it's like it's just not a good venue for me to like learn things, I guess. So And I think when you say it face that value, but I need to like open a book or website or a video or something to actually like learn it. I guess you could actually set this equal to like, they're probably doing like, yeah, alpha and alpha plus 1. Let's go through and solve this. It looks, I would say it looks fun. It doesn't look that fun, but it looks kind of fun. Have to do some equating of coefficients here. Okay. So what is our initial quadratic here? X squared minus, wait, x squared minus k plus 2x was it plus k plus 1? Okay, yeah. Well, 0, and we know that we have consecutive roots. So if we have consecutive roots, it looks like this person is saying they're using alpha and beta. So let's call our first root alpha, and since it is consecutive, our second root is alpha plus 1. So what we need to do is multiply this thing out and equate our coefficients, which we'll see what that actually means in a minute. So we get x times x is x squared, x times alpha plus 1 is x times alpha plus 1. Don't even bother to multiply that out yet. Alpha times x is alpha x. Alpha times alpha plus 1 is going to be alpha squared plus alpha equals 0. All right. Take those two terms, factor the x out, and factor the x. You get alpha plus alpha is 2 alpha plus 1 times x plus alpha squared plus alpha equals 0. All right. Now we equate coefficients. We have a 1 here, we have a 1 there. 1 equals 1. We already knew that. That doesn't mean too much. But we do get 2 alpha plus 1 equals k plus 2. Oh, are we going to have a problem here? No, we won't. And oops, I should actually write out the thing, k plus 2. And then we also have alpha squared plus alpha must be equal to the other constant, k plus 1. Okay. Now we have two equations and two unknowns, so let's solve. I guess we want to take this one, isolate k. Plug it in over there. 2 alpha plus 1 equals alpha squared plus alpha. 1 plus 2 is 3. So bring these two over here. You get 0 equals alpha squared minus alpha plus 2. 0 equals alpha plus 2. No, wait. That's not factorable, dude. Are you kidding me? If that was a minus 2, would be fine. Really? What's the quadratic formula give us here? It's imaginary? No, I did something wrong. It can't be imaginary. Is this supposed to be minus? Is that what I did wrong? I think we need the minus sign. That's still not right. That's still imaginary. Well, what the heck? What if I try isolating this k and, like, am I just... This should... Why does this give me something that works? That's so weird. Did I do something wrong the last time? Is that what that means? Or I think we should get the same thing no matter which way we do it. Either way, we have two potential answers here. Either alpha equals -1 or alpha equals -2. I guess we try them both and see... Well, I guess we should figure out what k is also, right? Plug in -1 there. Get -1 back out. Plug in -2. Get +1. All right. So what we need to do is multiply out x. Oh, you do x minus alpha. I flipped the signs. I think so there, if you take k equals, it should be +1, I think. This matches that. Now I want to redo this. It should be okay? Oh, maybe it still is okay. I just got the flip, but you still get that it should be x -1, x -2. So, and then I guess it shouldn't work with -2. I mean, I assume we'll only get one answer here. For alpha. What is that noise? Oh, that was a song. Okay, I was like, it smells like gurgling in my ear. This one does not work, right? Because k equals... There's no value of k to make that match. I'm just going to keep waving my arm until I convince myself of it. Right. Because this would be one more than that, but it's not. It's one less. Okay. So alpha equals, in my version, -1. I think in the way they're supposed to do it, they should get +1. Okay. Someone beat me to it. I think that's the same thing. That's basically a change of variables, isn't it, Suki? Oh, they deleted it. Okay, they got their own answer. Because I'm looking at alpha in the one forward, but you could look at alpha in the one behind it, and you should get the same answer. You should end up with the same thing. I think. that definitely x minus 1 times x minus 2 does work for the format. Is always getting like an imaginary thing, maybe? Or like imaginary roots? I might have gotten to the right answer for the wrong reason. I definitely should have been more careful with the minus sign there. Yeah, over on YouTube. Yeah, which series is that? Because we found that k should equal 1. Or sorry, -1. No, 1. If k equals 1, you get x squared minus 3x plus 2, which definitely factors to have consecutive roots, but I don't know. Yeah, I should have been more careful, but I think I just was able to get there, and I would, if the person didn't delete their thread, I would post it not in the way that I said it, or not in the way that I did it. Okay, so yeah, you're saying u sub n equals sum from k equals 0 to n of 1 over n plus k. Huh. The limit of this series. I was making a different type of series. When you say the limit, are you saying like as n approaches infinity? Yo, Zach! Thank you very much for the raid. Welcome in, everyone. I want to say it diverges because it's like the harmonic series. But the harmonic series is greater than that. See, comparison test doesn't work. Oh, really? You sandwich it between 1/2 and 1. So this is from Yaya over on YouTube. They need the limit of this series as n goes to infinity. Oh, wait. Is n plus k in the denominator, or is it 1 over n plus k? Like, is it... we should clarify that, I guess. Is it... So yeah, is it like 1 over n plus k, or 1 over n plus k? That's probably important to straighten that piece out. The second one? Okay, yeah, so they are both in the denominator. So it's over. So this is like a normal series that I would have encountered in my calculus class. That's what I think, Zach. And I want to say this is a change of variables, maybe, from the harmonic series, and it should diverge. I'm not sure how you would have gotten that it's between 1/2 and 1. Well, I guess I can see how maybe you did that. You're pretty confident it converges? Okay. And then ZZ on YouTube says it looks like it diverges. uh, Got the harmonic series somewhere and it still diverges. Hmm. I'm not searching the right thing, I think. Reductio. Oh, by contradiction. I guess the phrasing of it, it's not like how I would normally see a question phrased. Whenever I've encountered a problem like this. So if I'm going to rewrite the question, it's the limit as n goes to infinity, sum k equals 1 to n, 1 over n plus k. Like, and I guess how I'm used to seeing it, is this fundamentally different from how I'm used to seeing it, which is n equals 1 to infinity, 1 over n? That's what I'm trying to figure out, if these two are basically the same thing. Because it feels like they should be. I'm not sure though. They're not the same? Yeah, underscore. What's the magic word? Was possibly the same? Because you still get, well, I don't mean literally the exact same thing in the way that I wrote it, but you still get like a third plus a fourth plus a fifth plus a sixth plus a seventh in either case. Oh, are you, so okay, put k in the range 1 is less than or equal to k is less than or equal to n. But yes, because I was thinking that this shouldn't, I was thinking it should diverge. And if you're looking for some way to re-express it as the harmonic series more explicitly, I mean, maybe that's not possible. You need the value limit Riemann sum? Oh. I guess this is... Maybe I should have thought about that a lot sooner. I guess, yeah, this is probably just a Riemann sum, isn't it? We need to look at the, I need to look at the formula to remember, oops. Why? Okay, there. Well, just because each term is less than 1 doesn't mean it diverges, which is what I was thinking. Oh man, I've seen these problems before. I just need to remember, like, what the heck do you actually Google to find this? Converting Riemann sum to definite integral. It's definitely an integral. Let's get this one. So, it's something to do with this. I just want to see if they like do an example or something. Converting to an integral does seem like the smart thing to do here, but I'm still trying to puzzle out how we make the individual pieces here match with the format for a Riemann sum. Do we need to do some kind of fancy like plus n minus n in the numerator or something? Or plus n plus k minus n plus k? approaches ln2. But it looks like the n plus k are both stuck in the denominator there. I'm trying to figure out how to get them not. Like, these examples are all like very clear what the function is supposed to be. This one, I assume it's going to be 1 over n. Or, you know, like you're going to have to integrate 1 over n at some point here, or 1 over x. I just don't know how you bridge the gap from the start of the problem to that integral. Oh, you factor the n out? All right, that's pretty cheeky. That seems like the exact thing that we should do, though. I'm definitely not good at these types of problems, so I'm going to need to know the next step too, but. Okay. And x, so the delta x is this part here. And yeah, exactly. This is like, it's not even the first time that's so someone has asked me a question right after we talk about it in real analysis. I mean, this particular problem we obviously haven't gotten to, but like, it's kind of funny how those topics keep getting brought back up. Try to match the format that I'm seeing on this example problem. So is the function is 1 over x. So then are we saying that we take the bottom as our x sub I here? No, maybe? Which, wait, what do I do with the I? Oh, I just missed an I somewhere. Oh, I was matching the, that should be K. I was like, why is there suddenly an I here? That makes no sense. That's because I'm following the example problem too closely. Okay, so A equals 1. That's how we get that. Delta X is equal to A minus B over N. Delta X we know is 1 over N. A we know is 1. Which means, wait, that gives B... Why is the sign wrong? This should be B equals 2. I'm getting B equals 0. It's not good. Is it? No, it's B minus A, isn't it? They even, yeah, that's B minus A. Okay, so B equals 2. Okay, now we know what we... All right, so yeah, I'm sorry, this is a horrible explanation. I didn't even see the problem for myself. Even then, these problems are always like super weird for me, but the key is you have to convert it to an integral and recognize that it's like the integral from 1 to 1 over x dx. And I don't have a very good way of explaining the big picture of the transition from here to here, I guess. It just looks like 1 over x, unfortunately. I don't understand these problems well enough to explain them well, so I'm really sorry about that. I'm gonna look at chat in a second, see if someone is gonna educate me. ln of 1 is 0, so you just get ln of 2. That's funny. I assume ln of 2 is gonna be between 1/2 and 1. Yeah, you're exactly right. You convert it in, or you recognize that it's a Riemann sum, and you convert it to the integral. In that conversion, like, I have the intuitive feel for, but I've only done these problems a couple of times ever, so I don't have a good way of explaining it to others, unfortunately. You don't think this is the only way? You're probably right. I'm not going to be able to think of another way, though. It is between 1/2 and 1. So yeah, I mean, I guess I did find this slideshow here to be helpful, so I'll put a link there if you want to see more examples. These problems are very difficult for me. I normally when I explain things, or normally when I have a good explanation for them, it's because I've done the problem a million times. When I have a new concept here like this, I just don't have a good explanation for it. It's going good, ZZZ. Thanks for asking. Yeah, it's kind of the usual. Yeah, no problem. Yeah, I'm sorry I don't have a better explanation, but I hope I at least helped you out a little bit there. Were you first? Nah, you weren't first. Unless you're talking about something else. A casual graphic function with the rectangle approximation of the area under is the way to go. I don't really know how you draw a graph if you only knew the series. Because drawing the graph requires you to know what the function looks like, but how do you know what the function looks like until you already know how to manipulate the series, I guess. You're always the first? Oh, my bad. Wait, I forget who. Well, what's your name on Twitch? I think you said, but I kind of forgot. Then take v equals 3 pi x. You didn't, you keep it a mystery? Oh, all right. Fair enough. There's a few people who say that they're always first, so I guess there's a few candidates for who you could be. Yeah, but how do you know what f of x sub I is, underscore? That's what I'm... Unless you already... Like, I'm thinking from point of view of someone who doesn't already know what the function looks like, I guess. Like, how do you figure out what the function looks like in the first place? But you still are just pulling the 1 over x out of thin air, underscore. That's why I have trouble explaining this problem to someone else. Because I could see how it looks like 1 over x, but someone who's completely new to solving problems like this might not know that it's 1 over x. It's like that's the part that I can't explain. And you don't have to like, if you don't have a good explanation for it either, I completely understand, but that's the essence of why I don't have a good explanation for this problem. I don't know how you get to 1 over x besides saying just look at it, and that's not a reasonable way to explain the thing. Mm. As an answer, unsure of part C. It should be whatever sample proportion they got, and then root NPQ, I think. Which distribution should you use for this problem? Population proportion. Oh wait, it's PQ over N. I don't know why it's the standard deviation is PQ over N, and then but your little like test thing. I guess that's for student T distribution. It's weird, but no, this does look familiar now that I actually see it. They're only asking about part C as far as I know. They did post the entire problem, which is nice, but I'm gonna drop the hat just for the sake of I don't know. They're not even. I'm not in that text. They're not even writing the hat either. I need my math symbols again. On the actual square root symbol, because I feel like they might not understand the SQRT thing. And I think the sample size is 400. Yeah. Okay. Let's look for a new one. That's a logarithmic function. Hey, Tiny Pocket Girl. I'll help out with any math question that I know. I have a bachelor's in applied math, so I think I'd be able to answer the questions that your 10-year-old is working on. You know, my browser is slightly not aligned, and it's annoying me now. Okay. No, it's still not aligned. It's better though. Yo, Tay, how's it going? Glad to have you. And then Tiny Puckerel, if there's a question now, feel free to like type it out there in the chat, and I can tell you how I do it. It's going good? Awesome. Yeah, it's good to have you here. I'm sure one day you won't be as busy. At least hopefully. A logarithm look at the function from left to right. Is it going up or down? Here it's going up, so we'd say it's increasing. It does kind of it never quite goes flat. Increasing. That might be where they're getting tripped up on, where like it looks like it's almost like a straight line, but it's never quite. It's been a bit slower this week, which has been nice. Taking advantage of that and just sleeping. Oh, dude. That's a good idea, yeah. Just catch up on your sleep. Division times question, like 10 boxes, 300 each. Oh, okay. So yeah, if the question is like you have 10 boxes and they cost $300 each, in that case you'd want to multiply it. So your answer would be, I guess, oh wait, oh no, what does each box cost? Maybe the question is like misphrased, but is it 10 boxes for 300 total? Or is it 10 boxes for 300 each? I've been terrible to sleep lately. I feel like I'm up all night. It's frustrating. I kind of feel the same way, Tate. Like I've been like staying up way too late. Although I'm probably not as busy as you are from how it sounds, but I at least feel you a bit on the sleep schedule thing. Yeah, it's basically what ZZZ said, where if you have okay, so each box is 300, and if you're asking for the total for 6 boxes, that's when you do 300 times 6. So you would get $1,800. So it's some expensive boxes. That's what the answer would be. But yeah, like questions like that I can definitely help with. It's how it's worded he's confused with. Yeah, it's definitely tricky. Like, I bet he could probably like do the actual math, but knowing what math to do when it's a word problem is always like the hard part. Or, it's often like the problem that students have. It's a good way of knowing that you should do multiplication there. Because for me, I don't, I've done the problem so many times that I just know to do multiplication, but for someone who's just learning it, the kind of thing that you have to, I guess, realize is that if you're getting 6 boxes at 300 each, it's like you're doing $300 plus $300 plus $300 6 times. And adding 300 to itself 6 times is multiplication. Private tutoring, not really. I can have to answer questions through the stream, but I just don't have a lot of time right now to do private tutoring. when it's divided or multiplied depending on the question. Oh, no, you're completely fine. Because that is a very good question that it's kind of tricky to explain because it always depends on the situation. You kind of need to think about like maybe kind of one way to think about it is if you're given total and want the thing for each, you do division. If you're given the thing for each and you want the total, let me write that out. So there's like a different way that you can think about it with like units as well. So I think there's a trick here where you can kind of look at the wording and translate it into math symbols. So let me try and like write out what I'm thinking here. Why did I write B? Okay, so in the problem that we were given, we had actually you said 6 boxes. Six boxes cost 300 each. How much do they cost total? So how should I phrase this? I guess they're asking for total, which means we're going to multiply. Maybe that's a rule that like we could say, because we're given No, I think I make it too complicated if I say the next thing. It's almost like you're given a rate. I guess all this might be a little bit too like much, and an amount. And if you want to get the total, you need multiplication for this situation. So 6 boxes times $300 per box. Maybe I'll say per. I'll actually like write out per box. Is equal to 1,800 total. And then I'll give a different explanation for division here in a second, but let me make sure. Oh, Sia underscore. Yes. Okay. So I just want to make sure that there wasn't anything like pressing in chat, but so that's kind of how I break it down for like how we know in this case, or in this case, I knew to multiply here. Let's give a different version of the problem where you'd want to divide. I'll do it in, I guess, red. Instead, we're given, let's say, 6 boxes. That cost total 1,800. What is the price per box? So here it's still, we have like an amount, a rate, and a total, but we're given different parts of it. So we still have an amount here. we have a total here, but they're asking for a rate. And if they're asking for a rate, we need to do division because division represents a rate. So like these are very like related. It just depends on what information we're given, I guess, in the first place. So they're asking price per box, which means we want price first. Divided by, because per, I mean, also like here, like price per box, price divided box. So price divide 6 boxes. And we could also do it as a fraction. That's going to come out to 300 per box. And I don't know how they're teaching it these days, so they might do it as 1800 over 6 boxes. Same thing though. You could also do it as like over box as well. These mean the same thing. But yeah, I think the key is to think about things in terms of like a rate and what we're given in a total. So you'd also say a completely different context is if you're given, let me do it in black, I guess. If you are given, let's say you've driven for 3 hours at 60 miles per hour. I hope you're American, so these units make sense. How far, and the question is, how far have you driven? We can use the same exact logic here, even though it's a new context. So I would say 3 hours is our amount. 60 miles per hour is our rate. And I guess, you know, how far have you driven is the total. So they're asking for how was I writing it before? Oh yeah. Oh, I said multiply there, but I could have written total there. But they're asking for the total. So this is a multiply situation because they're asking for the total, just like they're asking in that first situation there. So you would take your 3 hours and multiply by your 60 miles per hour. And you get 180 miles. So I think that's generally how you want to figure out multiplication versus division, because they're very related. It depends on what pieces of the puzzle you're given, I guess. Which one you want to use. You're UK? Hey, Oveja, if I'm saying that right? Some people, you failed math? Oh yeah, I mean, I'm here to try and help people get through their math classes, so. Oh, I bet that sounds like a hard challenge with fractions too. You're UK? All right. We can say that these are kilometers, I guess. I'm just gonna say km. There you go. And look, I mean, you probably have driven like, you can probably do like 2 circles around the UK in 3 hours. So that's what I'm assuming, at least. I don't know. I've never been out of the country. Yeah, the fractions are definitely difficult too, and you can think of. I was simply trying to avoid it, but you could think of these problems as fractions as well. Like if you were to write it something more like this, but fractions are kind of challenging for their own reasons, so I was just trying to avoid them. But there's a different way that I could explain this that I was trying to like avoid involving fractions too. So I guess that helps you unpack that type of problem a little bit. Yeah, no problem. You don't do homework school? I never heard of homework school, so I guess not. Um, yeah, I'm sorry. It's kind of hard for me to like commit to like private tutoring like that, I guess. So I'm sorry. It's just like it's a I just don't have a whole lot of like spare time to do it. Like if you see me live, like I'd be happy to like, you know, try and explain it to your son, but it's hard for me to like do it outside of these hours. Math and English. Oh, I mean the English part I'm not too good with, but Obey, I hope I'm saying that right. Oh, homework about curves? Yeah, what's the problem? Oh, I completely botched this question. Wait. Um, Wait, did I botch this one? It's certainly not 1/2 to the x. What is this? Or maybe they mean... Okay, maybe it's that shifted around. Oh, okay. I'm just gonna leave it. Yeah, thank you for the question, Tiny Pocket Girl. Sorry that I, you know, can't do more, but if I'm live, I'm always happy to help with stuff. Okay, so it's a curve f whose domain is R. It satisfies the indicated conditions. Okay, so we have a generic function f. Okay, so let me draw out what it sounds like you're saying, Obeha, and I'll give you the explanation that I'm thinking. Okay, really, Marker? Yeah, actually, are you given a graph? So I think I know the idea of this. Or come up with a curve? All right, so we'll do a couple of examples, or like some that work and some that don't. Or like they all work. Well, no, they won't all work. Let's call this A f of A, and that B f of B. So what they're asking is to place an x, or to name a point somewhere between these 2 points, such that, let me actually write down what the condition is. X not equal to B. Right? Let me, oh, or you do have a graph. Either way, I can explain to you the idea and you can look at the graph for yourself, maybe too, but they're asking you to find where on the x-axis is every point after there less than this endpoint here. So actually, maybe I should put a different example for the first one. But like, this is the level here. And in this case, any x we can name besides b itself will give us a function value less than that, because this is just like the maximum value here. So you want to name the first one. So in a case like this, I would say x equals a, because x equals a itself is certainly like f of a is certainly less than f of b in the graph that I drew here, and every value after that never goes higher than f of b. So that's like the first one that we can name that works here. And I think that's what they want you to do, like the first one that you can name. So let's do a different scenario here and see how it's different. All right. Now if we try to take x equals a, we're fine until we get up to this point, but then this part of the function goes over f of b. So we need to keep coming around, and now when we get to this point, we dip back below f of b and we never go above it. So whatever this point is, we can name it. I'll just arbitrarily say that that's like 4 or something, you know. You might want to use some actual like hard numbers if you have to create a graph, but this is basically the idea here. Because after x equals 4, you're always below that like mark there. There is another scenario though, which is say you have something like that. Here, you can't name any value for x because x is not allowed to be b, and every x you can name before it is always going to be above your f of b. So here, there is no answer. Those are kind of, I think, the 3 scenarios. I don't think there's really another scenario that you'd have to necessarily worry about. That's kind of how you go about approaching a problem like that, as far as I'm reading it. Let me see what's going on in chat. A and B are intervals. Yeah, it's actually, they are intervals here too. So like you're saying, you're given an, it might be written like x belongs to a comma b, or just like maybe a comma b in parentheses, or even there's a different, depending on the country, you might do like a comma b like that. Are you given, like, if you're given something like that, this is still the exact same thing over here. The only thing that wouldn't work is if you have an open interval, like one of these where a isn't included, this scenario looks a bit different. Everything else is the exact same. So I wasn't being very like explicit about it, but what I drew, a and b, are basically the endpoints of the interval. Oops. So how's that sitting with you, Obeha, I guess? This music is kind of weird, I'm going to be honest. This song is a skipper. If you're on YouTube, you can't even hear the music in the first place, so. So in the meantime, let's work for more questions around there. Oh, what? You don't like metal? Nah, Gojira's awesome, and I won't hear anything else. Oh no, I'm not gonna know that one. Wiener deconvolution? I gotta read that one. Oh, your electricity went out, Oveja? Oh man, all right. Well, good luck with that. I'll see you around. Thank you for the question. Tolerate all kinds of elements? Oh, okay. Wiener deconvolution. Okay, sorry, I'm just 5 years old. Let's go to the math Discord for a question or two. I know I'm gonna be doing a ton of math today. Like I have been doing some like 6-hour long math streams. I don't know if I'm feeling like that today. But let's go for a bit longer here. Come on. There we go. So you can find a question here. No, I don't stream any games to YouTube. I wouldn't want to stream them to this channel. I'd want to stream them to the gaming channel. And setting that up in OBS, like having two different channels, YouTube channels synced at the same time is really annoying. So at least for now, I'm not streaming any of the gaming stuff to YouTube. Maybe one day I'll just get over it and do it, or I'll figure out a better way to do it. Gaussian kernel? I sure can't explain that. A lot of these are like pretty discussed. I was just doing induction for the Gauss's sum. Yeah, it's induction. It's not really represented the way that I'm quite used to, but oh. Hmm. Uh, I'm getting a little confused on like this conversation. It's part of why I don't like going in this Discord, because I'm just like, I just get confused with it. Hey Spetri, I saw you playing Elden Ring recently. Yeah, so it's really bad. I never actually beaten Elden Ring. I was super hyped for its release. I had it pre-ordered. I took a day off work because that came out when I had was working my job, and the PC release was so garbage on day one. I like every time an enemy would slash at me, my frames would drop, and in a game like that, that makes it unplayable. Like I was getting like 5 frames a second while enemies were slashing at me. It was impossible to dodge anything. So I was like, all right, F this. I'm gonna quit for now. And I just never got back into it. So I've been trying to get back into it because I know they're gonna release some DLC. If I can play like Dent. Yeah, so they probably patched it pretty quick, but I was just so disappointed that I just set it down and got distracted with other stuff, I guess. It's a little too hard to read that. Oh. So I probably wouldn't like stream it. Maybe I beat the game in time for the DLC. Actually, when is the DLC? Does it have a release date? June 21st. Oh. I mean, ideally I'll have beaten Elden Ring by then, so maybe I will play a DLC on stream. Spectre approved though, amazing game. My favorite From Software game? Yeah, that's another thing, like I wasn't super into an open world Dark Souls game. I kind of like them linear. I'm still absolutely going to beat Elden Ring, and I'm going to give it like as good a chance as I can. But I feel like I prefer. I'm still going to prefer the linear version without open world, I guess. Oh, wait. It's just asking to recognize which coefficients. Okay. How long have you played until now? Like how far have I gotten in the game? I've been clearing out Raya Lucaria, so I just beat the lady Renala. It is a beautiful game, and that boss fight has a really like amazing like cinematic with it, or like cutscene. That's where I'm at right now. I'm still working on getting to the first like kind of like big boss. I've seen him in like the trailer and stuff. The dude with all the arms, I think is who it's gonna be. So I assume there's like I'm not even close. Like I'm still in the very early stages of the game here, I think. So yeah, okay, 8, 5, and 2. I agree with that one. Which are the roots? That's gonna factor. You'll get 2x minus 1 and x plus 8. So I think you should get the third option. If you plug -8 into here, you get 16 times 2 is 32. minus 8 times 15. Oh wait, negative 8 does not work. What the heck? Wait, positive 8 definitely doesn't work. Wait. Am I stupid? Oh, it's 8 squared. Duh. You stopped playing at some point, but you think you'd be Raya Lucaria? Oh, okay. Yeah, it's like the wizard school area. If that helps, like, ring a bell. It's semester approved game, though. But you haven't beaten it? Oh, come on, man. Like, I'm gonna beat it. Have you played all the Soulsborne games? We've probably talked about this before, to be honest. Besides Elden Ring, I guess. So wait, let me try negative 8 again. So that's 64 times 2 is 128. Minus 8 times 15. 8 times 15 is like 30 times 4 is 120. And I said the other thing is 128. So negative 8 definitely works. Positive 8 definitely does not work. So they need to check their answer for number 2. And for number 4, I agree with their answer. Okay. Okay. Dark Souls because you heard it's the best. Okay, good. Like it. Those are 2 of my favorites. I have a soft spot for Dark Souls 2 because it was my first one. But if I'm being objective, I think Dark Souls 3 is the best Soulsborne game, followed very closely behind by Sekiro. I love both of those games so much. I love Dark Souls 2 even more, but I can't pretend that it's a good game. Or it's as good as the others. Team lead to finish it. It's hard to deny it's a great game. That's fair. Living DS2 is a hard fate in this world. Yeah. Oh, that's right. You're the reason why I went back and beat the DLC for Dark Souls 3, because I realized that I never did the second DLC. Gale's phenomenal fight? Yeah, it was really cool. I just love the whole theme that Dark Souls 3 like had with the whole like breaking of the cycle and like how the world was just so freaking destroyed at the end. A favorite boss? Oh god, I feel like you've asked me that before, but I feel like I also struggled for an answer. I gotta think. There's a boss in the DLC for Dark Souls 2 and one of them that comes to mind. Let me I feel like I want to go through the list of all three of the Souls games. Because in Dark Souls 1, the Artorias fight is really cool too. But let me see. Dark Souls 2 last DLC. Crown of the Ivory King. The final one in this DLC was so cool. They should list the bosses here somewhere, right? Here we go. Ivory King. It doesn't show any screenshots, but you're in this, like... It's this really cool thing where you can, like, recruit soldiers to help you... What is happening in this chat? Can I not minimize this? Okay, fine. Like, you can even get, like, knights to, like, help you out with the fight, and, they, like, sacrifice themselves to, like, make the fight easier for you. And the arena that you do it in is just so cool. It's like this, you're on this platform surrounded by lava. I just really like love the look of this fight in Dark Souls 2. NPC, yeah. And like as you progress through the DLC, you like free them from like being trapped in like cells or like in rooms, and they go and help you. For Dark Souls 2, that's the one that comes to mind for me. I'm trying to think if there's anything else. Because the final boss fight in Dark Souls 2 is kind of lame. In the base game. What were the 4 big bosses in the first part? Lost Sinner, Rotten, Big Spider Lady, Queen. I don't remember the 4th one. It actually in that same DLC, there was like you fought like invisible tigers, I think, or something like that, and it was actually possible to do it. Ava the King's Pet, I think, was literally like invisible, or no? I don't remember. Barely visible. Oh, never mind. Yeah, you don't kill it while it's invisible. Oh, the old ivory. The big demon dude is the 4th like big boss in the first part of the game. Yeah, no, I can't think of a boss I like more in Dark Souls 2. And then I guess I'll have to choose one out of those. Dark Souls 1, I think it's definitely Artorias. Dark Souls 3 is really hard. I'd have to look at the bosses. Sorry, this is like... I can talk about Dark Souls all day. The Abyss Watch is pretty cool. Wolnir, I really love the look of that fight. Aldrich was cool. Oh, Osiris is cool too. One of the people who would actually like talk to you. Oh man, Nameless King though. Nameless King might just have to be the coolest one. Either that or honestly Gale. And also out of those, I might still go with the Dark Souls 2 bosses being my favorite. If I were to choose between the 3 of those. You used to be so stuck at Pontiff because you were shooting under level. Dude, that was a hard fight. Pontiff and Dancer were definitely like two of like the hardest bosses in that game, I think. Alright, I'm not finding a whole ton of more math to do, and I don't have much to study for real analysis. Let me make sure I have no new like replies on Reddit. Doesn't seem like it. Pumped like 5 potions and level 5 weapon. I mean, oh yeah, the 5 flasks is gonna be pretty rough. No, I actually do have a draw request from a few days ago. I wasn't doing math at the time, but Shep asked me to draw a cat in typical Shep fashion. You like the answer? I think it's a cool fight. I have a hard time liking that fight because I got so frustrated at it, but once you learn how to deal with her, it is kind of a cool fight. So I'm gonna do my cat drawing, and then maybe I'll do a little bit of Baba Is You here. At least on Twitch, I will. All right, so we need to do a cat for Shep. Bam. Get the other leg in there. Send most of the tail like curled around their legs, right? Just to mix things up a bit from how I normally draw a cat. And I feel like black cats normally have green eyes, so we can do that too. Oh, that's a weird nose. Didn't come out right. Kind of like triangular almost. I think that's my cat for Shep. I don't know, dude. I've drawn cats a million times now, but the head looks human kind of. Oh yeah, I like the shape of it. In your opinion, Sekiro's superior to the rest of the bunch? Yeah, I think Sekiro is my favorite combat out of any of the Souls games. I don't know. I have a hard time like choosing as my overall favorite Souls games, but I do love the combat. I love the theme. I love so much about it. I don't know why. I just like. I don't really say it's my favorite like Souls game though for some reason. I love everything about it though. Tell me Sekiro 2 of some sort. That'd be amazing. I've been trying to resist the urge to do another Sekiro playthrough because it's been a while and I feel like I'm like overdue, but I haven't been Elden Ring yet. Send Shep an image? Yeah, you're right. It's a good call. Oh man, I didn't realize that there's the glare on the whiteboard. The spot that I drew it. Oh well. Okay, took a screenshot. Oops, sorry about that. Whereas part of, yeah, it's part of the art, exactly. All right, let me quickly send this over to Shep. Where is Shep? There she is. Okay. So yeah, I don't have more math to do for the day, I think. I won't cut the stream off. For YouTube, I think I'm going to cut the stream off here. On Twitch, I'm going to be doing, I think Baba is You, because I haven't done that in a minute, and I do still enjoy that game. So yeah, if you're here on YouTube, I appreciate you. I'll be back on Thursday at the same time. But that's going to be it for the math from me for today, so thanks everyone for hanging out with me, and I'll be back on Thursday on YouTube.